Hi guys, Frankenstein here. Want us to look at the half wave power supply. So how can we do that? Let's start by knowing how is the circuit looking like, or the diagram itself looks like, or the figure. So how it looks is that you need to have a transformer at the starting point. You just step down that voltage. So the transformer there. Weird. Let me try and make it look more neater. Okay, there you go. And then we need to have our diodes there. So we're gonna have a diodes in the forward bias there. And then we have a resistor there. Where it's gonna act as our load. And then yeah, that's the next part. Actually looks weird when I try that way. Yeah, and that way it's fine. Okay, we've got that, and then we can put our ground there, reference point. And then yeah, ideally silicone there. And then what else is left? Okay, fine. So we know that this will be the primary point, and then this will be the secondary point. And then need to have our ratio. Remember, our ratio N1 stays here, N2 is on the secondary point. So that is the ratio is 2, and then they tell us the ratio is 10 is to 1. And then they tell us the supply voltage that is actually given to be 220. And remember, if you're not told what is that voltage will seek as a VRMS, right? It's fine. And then what else do we need? We told that the resistance of the load is actually 680 ohms. And that's it. And they're telling us that obviously you having an AC wave coming into play. So basically on the input in the input side, having a wave, something like that, right? And if you analyze that circuit, there is that during the positive cycle, put will be there. This wave will be on, so this will be transfigured into a certain wave like this. For this positive cycle, it will be there because the diode will be on. So meaning that current will flow to the positive, from the positive to the negative, right? During the positive cycle, yeah. So meaning that this one on the output side, it still appears. And then if I analyze it using the negative during this negative cycle, show it to the polarities will be changed. This will be positive, this one will be negative, so current will flow in this way. So this diode will be off in this during the cycle, it will be off. So surety this part will be just flat, so during the wave this will be just flat here, and then for the other positive cycle it will appear and so yeah, that's how it will basically appear on the output side. So I'm expecting to clip off the negative cycle, but the positive cycle will appear. So yeah, let's go into the calculations themselves, which are very important, that we know them, how to do them and perform them, because we're going to be asked to do that from the calculations. So let's say we're going to always analyze it according to the conventional current. So she would see always analyze most of the time according to the positive cycle. So let's say, for example, most of the time what we are going to be asked to find, we are always going to be asked to find E1 peak, E2 peak, Vmax, Vout, and we will later on find out that Vmax is equal to what? VDC, and then IDC, And also we must find PIV, which is the peak inverse voltage. So we need to find those 6 things. So this is number 1, number 2, number 3, number 4, 5, and 6 finally. So let's find each and every required thing there, right? So I'm gonna use a yellow one, like yellow, guys. So let's find E1 peak. So E1 peak, we know the formula. I've told you E1 peak is equal to, right, V RMS multiplied by root 2, right? And this VRMS is the one which is given the primary side. So I like usually using a subscript of primary just to make sure that you can see that. And then VRMS primary is actually 220 multiplied by root 2, and we should get our answer. Let's see how much is our answer. Pinch that. $220. Getting our answer to be 311.13 volts. Ne? And then, so that is our E1 peak. So you can answer it and say that E1 peak is equal to 311.13 volts. Ne? So we've happily answered the first question, and we know the formula on how to always, when they ask us for E1 peak, we use that formula there, that E1 peak is equal to VRMS primary side multiplied by the root 2. Ne? Now let's go into finding E2 peak. E2 peak, you're going to be always be asked to find it. How do you find it? You must always know your relationship to the voltage. So you know that E1 peak divided by E2 peak is equal to N1, 1 because there's 1 there, over N2, 2 because there's 2 there as well. Now, substituting what you have, we do know E1 peak is 311.13 divided by E2 peak is equal to N1. What is N1? N1 is 10 from there. Remember I told you N1 side, N2 side. So N1 is 10 divided by 1. So cross multiply, you find out that E2 peak is equal to 311.13 divided by 10. And we should get our answer as 31.1113 volts. So our E2 peak is equivalent to 31.113 volts. Ne? So the most important thing is to know your formula. This is very important formula. You must write it down in your notepad so that you don't forget it. And then we can go to the next one, where we are asked to find Vmax. Most of the time you are asked to find Vmax. Vmax is nothing else but subtracting the diode. Because remember, only one diode is on for each cycle, and remember here we only accounting for the positive cycle, so one diode is on for all the positive cycles, so only one diode you're going to be using. So meaning that Vmax is equal to E1 peak subtracting V diode. If it was 2 diodes, I would say 2 times diode, but now because it's 1 diode, it's 1 multiplied by V diode, which can just be V diode. So E1 peak is actually 31.113 minus 0.7. And how much should be our answer? Our answer is 30.41 volts. Ne? So Vmax is 30.41 volts. Ne? Now let's try and go into finding VR or VDC, but I like writing him as VDC. So VDC now equal to VR is equal to, remember, you must have what? V max there on top divided by pi, ne? And remember what I said is that it's because you go to find this formula, it's all about your calculus, but we don't explain all the variables, but we said that the output wave will be looking like something like this. Like that, and then the part will be clipped off, and then continuously, right? But if we check how many per cycle, so a cycle ends here, right? Cycle ends there. For that one cycle, how many Vmaxes can I see for this only one cycle from here? From there to there. How many Vmaxes? Because Vmax is here, so that's Vmax, right? For only this portion, how many Vmax can I see? One Vmax. So it will be 1 time Vmax divided by pi. So that is basically your V or your VDC. So it's gonna be Vmax divided by your pi. So yeah, that's how you can make sure that if it happens that you forget that formula there, you know you can always rely on the output waveform to tell you what is actually the formula for VDC. Remember? So that is equivalent to, sorry there, equivalent to Vmax. Vmax is 30.41 divided by pi. How much is our answer? Our answer is 9.68 volts. So V average or VDC is equal to 9.68 volts. Yeah? Now what we need to find is find IDC. How can we find IDC? IDC, remember, is just basically Ohm's law, but you must know what variables should be divided or multiplied within that Ohm's law. Remember, Ohm's law is VAR. So we're looking for current, so I is equal to V over R. Now, if we're looking for what we're looking for, you can always say it's going to be IDC. What voltage should I use? I must use VDC. What resistance should I use? The load. Ne? And then what is VDC? VDC is 9.68 divided by what is the load? The load is 680. So you punch that. The current flowing there is actually 14.24 milliamps. Yeah. So the current which we have is 14.24 milliamps. That is IDC. That is the current which is flowing through that load. Yeah. So what we need to find also now, it is the PIV. So similarly to the full wave bridge rectifier, it's the same one, because if you remember the full wave bridge rectifier, we said that PIV is equal to E2 peak, right? That's what we said, right? We said for the full wave bridge rectifier that PIV is equal to E2 peak, right? So we'll say that. So PIV even here is equal to E2 peak. The only difference is on the half wave, so not half wave, it's the center tab or the biphase. That is the one which has a thingy which is going to be 2 times Vmax. It's not going to be E2 peak. PIV is equal to 2 times what's this called? Vmax. Is it Vmax? Let's make sure. Yes, it's 2 times Vmax for the center tab or the biphase. But for the half wave power supply or the full wave bridge rectifier, it's basically PIV is equal to E2 peak. It doesn't change. So E2 peak is equal to what? 31.13 volts. So That is your PIV value. So you can put a little sine wave there just to show that it's also a sine wave. So yeah, that would be how would ideally solve for those. So let's just take a thing of it. So 31.13 volts. So yeah, that's how we solve these questions for the half wave power supply without a capacitor, by the way. So with the next videos, we're gonna be having some capacitors there, having some rippling voltage. But yeah, meet in the next one. Hopefully you enjoyed, guys. Cheers.